In this video, we'll go over a problem involving free fall. So the problem statement says there is a hot air balloon that is moving upward at a speed of 10 meters per second, and at the instant when it is 50 meters above the ground, a ball is going to be dropped from the hot air balloon. And the problem asks, what is the maximum height that the ball is going to reach after being dropped from the hot air balloon? A, max height. This is a good time to set the coordinate system. Coordinate system that is going to be chosen here is y equal to 0 is the ground, and upward is positive y. Gravity is pointing downward. To solve this problem, we're going to use one of the kinematic equations. A in this case is equal to negative g. G is the gravity, which is negative 9.8. Maximum height means the final velocity is 0. That's when you reach the maximum height. So v is 0. Therefore, the equation becomes squared minus 2 times 9.8 y minus y naught. So what do we put for v naught? When the ball is dropped from the hot air balloon, it will have the initial velocity that the hot air balloon has. So this is going to be 10. 0 is equal to 100 minus 2 times 9.8 y, which is what we're looking for. Y naught is right here when it is above the ground, 50 meters. If you solve for y, you get 55.10 meters. What this means is that the ball will actually go up and then it will go down. The ball starting from 50 will go up by 5.10 meters. Part B asks the total time the ball is in flight. The motion that the ball will have is this. Starting from here to maximum height, from maximum height to the ground. So, to find the total time, we would need the time for the red motion and the time for the green motion. So to do the time for the red motion, we will use this equation. V is equal to V naught plus AT. A is negative g, so V is equal to V naught minus GT, where A is equal to negative g. Maximum height, like we said in part A, means the final velocity is 0. So this is 0 is equal to, initial velocity is the same as the hot air balloon, which is 10 meters per second. 10 minus g. T then is equal to 10 divided by 9.8, which is g, equal to 1.02 seconds. To find the time for the green part, we will use another kinematic equation, which is V squared is equal to V naught squared plus 2a y minus y naught. v naught squared minus 2g y minus y naught. V naught in green is the same as v in red, because the final velocity for the red motion is the same as the initial velocity for the green motion. And this is equal to 0. You have v squared is equal to 0 minus 2g. So for the green motion of the ball, the final height y, which is y, is 0, which is the ground. So this is going to be 0 minus the initial height of the green motion is the maximum height, which is 55.10. And this becomes negative 2 times 9.8 times negative 55.10. Minus with the minus becomes plus, so you get v squared is equal to 2 times 9.8 times 55.10. V then is equal to square root of 2 times 9.8, 55.10, equal to to find the time in the green region, we do v. In the green region, the ball is going down, has velocity in the negative y direction, but also gravity is in the negative y direction. So this means that v and g, or v and the acceleration, have the same direction. So we can write this as 32.86 is equal to v naught, we said is 0, equal to 9.8 times d. If we want to be consistent with the coordinate system, we can write this as negative 32.86 is equal to negative 9.8 times time, because the velocity is going down and the acceleration is also pointing downward. So they both have the same sign. T then is equal to 3.35 seconds. To find the total time, we're going to add 3.35 plus 1.02, 4.37 seconds.